Hello guys, welcome back to my channel. Today we are going to be talking about data modeling in Power BI. Sit back and relax because it's going to be an interesting watch. So what is data modeling? Data modeling is the process of structuring and organizing data to create meaningful relationship between different data sets. Look at the keywords here, different data sets. It involves importing the data from different sources, could be web, it could be Excel, it could be CSV, it could be database, and so on. Defining the relationship between the tables and optimizing the data for analysis and visualization. In a nutshell, you are breaking data from different sources and creating a relationship between the data so that you can do a proper analysis and do data visualization. Right? So data modeling organize, and connect data effectively in Power BI to talk about organization of your data from different sources. And it also enable better insights and performance by structuring data properly. So there's an image, by bottom left here, right? This is a typical example of what data modeling is all about. So these data are gotten from different sources, right? And they are linked together. You can see, the arrows joining them together, the lines joining them together, different tables together. Don't worry, we're going to talk more about what this image is all about. Typically, this image was gotten from the data modeling pane inside of Power BI desktop. So now, in data modeling, there's what we call relationship cardinality, which simply means the nature of relationship between tables in a database or in a data model. This time around, or in this video, we are talking about a data model, specifying how many records in one table corresponds to record in another table. Right? So we are talking about the fact table, the dimension table, etc. Right? So the main types of cardinality in relationship, or the main types of relationship cardinality, are first one to one, which is each record in table A relates to only one record in table B. For instance, you have one record in customer table and we have also one record in the order or sales table. Two, one to many. In this kind of a relationship, a single record in table A can have multiple records in table B. For instance, customer name in table A or customer table can have as many records in the sales table, right? So that means customer can place order as many times as possible. I repeat, one single customer can place an order or can purchase something from a company as many times as possible. So this is like the most used and common type of relationship in Power BI or data modeling. Right, that's second. Then the third one is the many to many. From the name, many records are present in one table, say customer table, and also many records are present in another table, say sales table. However, you need to be very, very sure of what you are doing because you might run into a lot of problem using this kind of relationship. You can see multiple records are in table A can relate to multiple records in table B, requiring bridge to manage relationship. All right. So now this is typically we have like if you are to look at it based on this, we are supposed to have like four different kind of relationship cardinality, but I've broken one to many and many to one as the same thing. All right. So over here with this diagram, you can see the different kind of relationship cardinality. So this is one to one. That means the record is in table A and only one record also is in table B. One to many, which is the most important or the most common one that you always want to use, is that in table A, you have one record, or when I say the customer ID or the customer name, and you have many records of that customer in the table B or the sales or other table. So many to one is the same thing with one to many. While the last one, many to many, you can see many record in table A for one individual and many record in table B for that same individual, right? So that is what this is all about. Now, star schema. So what are schemas? So if you're into data as a beginner, you have heard of schema. So a schema is a structured framework that defines the organization of data in a database. It's just the how organized the data are. It specifies how data is stored, related, managed, including tables, field, relationship, constraint, and data type. You understand? So we have just two main types of schema. So we have the star schema, which is like the most common one, and the snowflake schema. Star schema consists of one central fact table connected to multiple dimension tables. So this is a typical example of a star schema. As you can see, it takes the shape of a star. So you have one central fact table, which is the table here, most likely your sales record, and several other dimension tables, which could be your employee table, your customer table, your product table, your shipping table, your territory table, and so on and so forth. Right? So that is uh, what a star schema. Typically, you're going to have a central fact table with as many records as possible, probably 500,000 records, a million records, and so. Why the dimension table they are very minimal in terms of how many records are there. For instance, now for a product table, you might not have more than 20 or 30 records. Employee table, maybe like 40 or 50 records. Territory table, maybe 10 or less record, right? So that is what star schema is all about, which is also the most used or the most common schemas that you have out there. So the second one is the Snowflake schema. So Snowflake is a normalized version of star schema with dimension tables split further, for better performance. So you can see now, so you have the fact table here, which is in the middle. However, you now have the dimension and circle, right? So you can see now that this store is connected to the sales table. It's also connected to geography table, and geography table is connected to customer table. So that is Snowflake schema. But in a star schema, only one of the dimension table is connected to the fact table in a star-like shape. So you don't have something like this, or something like this, or something like this, or this. No, it is only connected to the central fact table. Like I said, this is the most used. You can note, star schema is recommended for Power BI for better performance. Star schema is what you should be using, right? So now let's take us back to what I said earlier. Sam, look at this particular um data modeling image now. So you have different um dimensions. All right. So these are dimensions. We have the employee table, the reseller table, the promotion table, the product, the territory. You understand? Then you have the department. So all of these are dimension table, customer. Then you have the central fact table. So sometimes, in some cases, I've seen a situation whereby you can have probably more than one star or more than one fact table, right? So you can see now we have the internet sales table, which I believe is like the main fact table, being connected to each and every one of them. Now, you recall a few minutes ago we talked about relationship cardinality, right? So where we have a one to one, one to many, many to one, and so on. Yeah. So one to one. So one to one, like I said, is when you have one record in a table and also have one record in another table. And I also mentioned that the most common types of relationship cardinality is the one to many kind of relationship. And I'm going to show it to you here in this particular image. So you can see, like I mentioned, these are dimensions, right? Okay, now if you look below each of the table, you will see that there is a particular letter there. There's a number which is one. So we have one on all of these dimension tables. Then if you look at the fact tables, you can see that there is a star there. So star means many. So it means that you have many of the records in the fact table, but one of that particular record in the dimension table. So this relationship is known as one to many relationship. And again, when you are establishing relationship, there must be a certain condition that needs to be met, right? So the condition is that there must be a column that will be present in the dimension table and also be present in the fact table. Again, there must be a common column in the dimension table and also a common column in the fact table for a relationship to take place. If you check again, if you check it very well, you will see the lines here. You can see this is the connection star to ash. That means star many to one, right? One to many, and this is a relationship. So this is the line that joins them together. Okay, so please take note of that. So now, when I was talking about the common variable or the common column that may be that will be in the same table. So let's take for instance now the product table, which is a dimension. So it's going to have fewer records, like fewer rows, maybe like 30 or 40 or thereabouts, depending on the content. So you can see that the product table has something called the product key, as a variable or a column called product key. Then also the internet sales table also have a column called the product key. It is on these columns that we create a relationship between the product table and the internet sales table. All right. So look also again the customer table below. So the customer table has a particular column called customer key, and the internet sales also have customer key, right? So it is based on this column that will create a relationship between the two. Now, to portray what I said earlier, what this means here is that in this customer table, you have things like a customer key, let's say customer key or customer code, let's say 001 as the customer code or customer key. Then you also have things like address of the customer, the street address, the date of birth, blah blah blah, and so on and so forth. Information about the customer. So let's say customer ID 001 is Ahmed Ola, right? So you can only have Ahmed Ola information once in the customer table. So you have Ahmed Ola's customer key, his address, his street address, his phone number, his email, his date of birth, and so on and so forth. Then you have another customer, 002, Yemi Kuti. So Yemi Kuti too, we have all the profile or is our own profile, similar thing that we have for Ahmed. And so Ahmed Ola or any other person will only appear once inside of the customer table, right? But Ahmed Ola can actually buy as many products as possible, and his sales will be recorded inside the internet sales table. So Ahmed Ola can buy a product today, can buy tomorrow, can buy next tomorrow, can buy like 7 times in a week. So his name and his customer key will appear 7 times in a week in the internet sales table, right? So that another thing that this also gives you the advantage is that it can also enable you to filter on the customer table, the dimension table, and you will get all the records in the filter table. Okay. So same thing, for instance, now look at this now. Let me based on this now. what I just explained now, because it's featuring, cross featuring. So for instance, now we have the employee key here, right? And we have the employee key here too. So that's how why there's a relationship. So look at this arrow now. Look at the line from the employee table. Then it moved to the seller sales table. So there's an arrow here facing the reseller table. Right. Let me zoom on it very well. So you can see the arrow. It means that this guy can filter all the records that is in the reseller sales table because the arrow is pointing towards the reseller, right? You can see. So these are the things that you need to take note of if you are building your data model, right? So you want to look at the direction of the arrow in case you want to filter. Sometimes you might do both filtering. So the both filtering will now look something like this. That means I can filter from the fact table to the dimension table or from the dimension table to the fact table. But the best practice is to be in a single direction whereby only the dimension table can filter the fact table like we have in this instance. Right? So these are the things that you need to note when you are building your data models. Joining table, so we have active and inactive relationship. Active relationship are very preferred. So this is what we mean by active relationship. You can see the thick arrow. So these are active relationship. But the fainted one or the dotted ones, these are the inactive. Right? So these are active. But you can see the dotted one here. They are the inactive. So please always ensure that's a course for another day. Talk about active and inactive. But always ensure that you have active relationship. Then again, single versus bidirectional in table journey. So single direction is default. Bidirection should be used with caution. So I mentioned this earlier, right? So this is single direction, whereby you have the arrow, from the dimension table facing the fact table. Bidirectional is when they can both filter each other. So it will look something like this. One will face here and the other one will face like this. So I can move to this place and I can move to this place also. Right. So but you always want to perform a single direction. So all the um joining or relationship here, it is single direction, not a bi-direction. Okay. So that is what you can also do some tax functions to perform some join and lookup and all of that, right? So I hope with this now, once you have a good understanding of all the terms and the concepts and all the properties of the table, um, modeling the table should not be an issue. So before we go to what we are the practical, we need to quickly understand the business model or the case study that we want to use. So we are using Owonikoko e-commerce business, which involve the buying of the selling of goods over the internet. I mean, most of you have shop online and all of that. It's an e-commerce business. So right here I have the explanation of variables and the relationship between the tables for the e-commerce business. So the data set consists of 5 tables: the orders, the customers, the product, shipping, and the people table. Here is a breakdown of the variables in each table and how they relate to each other or to one another. So the first one is the customers table, right? So this table contains information only about the customers that place orders, only the customer that place orders, right? So I have, the variable, the data type, and the description. So these are the variables or the columns, right? So the first column is the customer ID. The data type of the customer ID is an integer, and this is a unique identifier for each customer, which are basically the primary key. Primary keys are unique identifier, right? So the second variable is the customer name, maybe Ahmed or Yanekuti. So this is a string or a text variable or a text or a string data type. which is basically the name of the customer. The third variable is the email of the customer. The data type of that is a string, of course, the email address of that particular customer. Then the location of the customer. It could be a city, a state, or where the customer is based. So in order design, there can be as many variables as many columns about the customer. For instance, like the date of birth, like the phone number, like the address, like just mention as many things about the customer as possible. But with this data, we are focusing basically on four variables: customer ID, the customer name, email, and the location. Very simple. Now, this is the relationship with the other table. So the relationship that the customer table have is a one-to-many relationship with others table. We're going to look at other tables later on. So what it means is that a customer can place multiple orders. Amendola can place multiple orders. However, each order is linked to a customer. So order ID 005 can be linked to a particular customer, right? So customer ID is going to be a foreign key in another table. A foreign key is a primary key in another table. So customer ID in the customer table is a primary key. Customer ID in the order table is going to be a foreign key, right? So that is the relationship that exists between the customer table and the order table. So the second table is the product table. So for product table, we have the variable, just like the customer table. The variables are product ID, the product name, category, and the price. While the relationship one to many again. So most of them have a one to many relationship. In fact, all of them have a one to many relationship with the orders table. So a product can be ordered multiple times. Each order contains a specific product. Product ID is a foreign key. Again, I think each order can also contain as many products as possible. So for a particular order now, I can have like 3, 4, 5 products also. Right. So this varies. This depends on the environment. For some company, they may say for every order, it should just be one particular product. In some, which is like the common one, the commonest one is a particular order can have as many products as possible. So my order ID can be 005. I can be buying a pair of shoe, a bag, a laptop, and probably a socks. Those are 4 different products under one single order. Okay, so that is the explanation. So now the third one is the orders table, which is like the fact table in this instance. So you have the following records: the order ID, customer ID, product ID, and so on and so forth. Right. So the order ID is the primary key. The primary keys are very simple. It's just a unique ID of a particular table. Right. Each row is going to have a unique identity, and that's the primary key. Then you're going to have the customer ID inside of the order table, which is the foreign key. Foreign keys are primary keys in another table, right? So customer ID is a primary key in the customer table. So the product ID, also a foreign key, which is an integer. The order date is a date data type. It's when the orders have been placed. Then the quantity is going to be an integer, which are numbers. Then the total price is going to be float, which are also numbers. So you can type price. So now the total price is just the quantity multiplied by the price. Now, so the relationship. So this one has one to many relationship with customer again. So a customer can place multiple orders, right? One to many with products. Each order is associated with the product. One to one with shipping. It means that that item is 1 in the order table. You can also have an order ID, and you can also have just that same order ID in the shipping table. So let's say order ID 001 now. Who is going to take out order ID 001? Maybe to an individual. So you are going to, in the shipping table, you are going to have the ID 001 also. Then you have the shipping information. Maybe it's going to Abuja, it's going to be a first class shipping mode, and so on and so forth. And maybe it's going to be cheap for like whatever amount of money. Okay. So then we have one to one with people. We also have a people table. So who is going to take this order out? If the order ID is 001, then the people table is going to be also 001, so that we can know that okay, order ID 001 consists of how many products and who is in charge. Right. So these relationships are very important when you are designing your data model. So then the shipping table. So the shipping table has these variables, right? There's the shipping ID, okay, which is an integer, the order ID from another table, the shipping date, the carrier, name of the company that's going to ship the product, and the status, whether it has been delivered, shipped, or in transit, or even pending. So you can see the relationship is 1 to 1 with others. Each order has one shipping record. It's as simple as that. So for an order, we are going to have a single record. Order ID is the foreign key linking to the orders table. So if I see any order ID in the shipping table, it can be easily traced to the orders table, and I can get all the informations inside of the orders table in terms of the products. So I can get all of, by knowing the order ID here, I can have access to all of this information. Okay, so that is what that one is all about. Then the people table. So the people table has the employee ID, or you can say it's an employee table also. Then the employee name, the role of the employee, and the order ID. The data type, integer, string. Of course, so the goal of the employees is either you are a sales, you are a support, or a manager. So relationship also 1 to 1 with others. Each order is handled by a single employee. Order ID is a foreign key linking to just like a shipping the shipping table with the shipping ID that with the order ID in the shipping table. Same thing with the people table. So order ID in this place, order ID in the people table is being linked to order ID in the order table. So once I know the order ID, I can easily get all the information about the order in terms of the name, the customer, phone number, etc. Right. So summary of the table. So for customer have one to many relationship. That is, orders. One customer can place multiple orders. Ahmed can place multiple orders, even like 5 times in a day and 2 times every other day. But each order is linked to one customer. It can only be linked to me. All the 10 orders that are placed in a day can only be linked to me. Then the second one is the product information, which is also one to many. One product can be ordered multiple times. You understand? I can order a shoe, bag, a laptop, a mouse, a table, but each order contains only one product, right? So each row of order is for a single product, although the order IDs can be replicated, right? So the orders one-to-one orders to shipping is a one-to-one relationship, which is each order has only one corresponding shipping record. If my order ID is 005, for instance, now, right? So it can only be assigned to a particular shipping information. Maybe it is UPA that is going to deliver my order, and they can get all the information of my orders. So 005 will appear once in the order table, and 005 will appear once in the shipping table. It cannot appear more than once because you only have one order that's 005. Same thing for the orders to people table also. Each order is managed by one employee. That is our design. So 005, we also have 005 in the people table because we have assigned one order per person, right? So once you understand the design, although it might vary by company, some company might might assign maybe one order to two or more people, but or two or more orders to one person. But in this business model, in this Owonikoko business order, one order is to be managed by one person. So once you have an understanding of all of this, then we can now go to our Power BI and start the practical. However, before we start with the practical, again, let me show you how the data look like. So we have five different sheets of obviously five different tables that we talk about. So the first one here is the customer table. So you can see the customer ID. So we have just 10 customers, their customer name, their email, and the location of each of these customers. All right. So the second table is the orders table. So if I do a control shift down, we have all like the 36 records here. So you have the order ID, the customer ID, the product ID, order day, the quantity, and the total price. This is our order table, right? So the products have 10 different products. Product ID, so the product name, the product ID 101 is a laptop. It falls under the electronic category, and this is a price. Rank, rank chair is a furniture, tablets, and so on and so forth. So this is the shipping information. So you can see each order. You can see their unique um shipping IDs. You understand? So the order IDs, these are the order IDs. So you can see that they are also unique. So one shipping ID for one order. Then the shipping date can vary. So the carrier. So if I click on this filter button, so we have four different carriers for to ship our product to our customers. So this is the status of each and every one of them. So they have the deliver, in transit, pending, or shipped. So this is the shipping information. Then the last one is the people table. So you can see the employee ID or the person. So employee ID 301 is John, it is in sales, and this is the order ID we expect him to, to ship. You can see it's also unique across board. We are not going to have, two things repeated, two order ID repeated. So once you have all this information, now we are going to head over, to Power BI. So once I've downloaded and installed your Power BI, it will show you something like this. Then I'm going to click on blank reports. Yeah. So the first thing I want to do, obviously, is to bring the data in. So my data is in Excel. Anyway, so I'm going to click on Excel workbook. Then I just need to locate the particular data set I'm working on. So the data set is Owonekoko e-commerce data. Okay, so I have all of this table and this sheet. Okay, so you can select all of them, right? So I'm going to click on load. So I've selected all the five tables. So this might take time depending on the number of tables and probably the RAM size or the performance of your laptop. So we have all of this successfully, loaded inside of our Power BI desktop. Customer ID, orders, actually customer ID, customers, orders, people, product, and shipping. All right. So if I come here now, this is the table view. You understand? So if I click on any of them, these are all the data inside each of the table. So that's the table view. Then the third one here is a model view. So you'll be surprised that the model has been in a way created by itself. So Power BI can automatically, model data once it can find, similar or corresponding columns or variables. in each of the tables. Okay, so let me collapse this. Yeah, so this is our modeling environment. So you can see, so let me just, so you can drag and drop each and every one of the table. So this is the shipping. So let me just put it here. Then our orders table is going to come in the middle, right? So the product table, let me just take that, okay, somewhere like this. The shipping from this place. Let me drag this. Uh, so So the point here is that Power BI will automatically, help you to model your data once you find matching columns. All right. So let's start from the customer here now. So this is a one to many, relationship. That is from customer to order. So one to many. Okay. So, and it is being, if you click on this now, it will tell you that they are being joined on the customer ID. So this is the orders table, and this is the customer table. Matching column, customer ID, right? So you can see cardinality that I talk about earlier on. Cardinality is many to one. Many in orders, then one in customers. And it's a single cross filter direction. So this is what I was talking about earlier in the PowerPoint presentation. So you can see it's a single direction. That means you can use, the columns in the customer table to filter what you have in the order table. Understand? So also again, you can change this to both. If you change it to both, which I won't advise, so you have something, let me save it first. So you can see now, you can see they are both directional. So it can be filtered to this area. So customer ID, customer table can filter the orders, and orders too can filter, the customer table. But like I said, it's not advisable. So I'm going to open the properties, then I'm going to return into single, then I'll save. Yeah, same thing go for the other ones too. So for this guy also, so the product table and the order table are joined together on the product ID, right? But and the, the shipping table and the order table are joined together on the order ID. Now, look at this now. It's telling us that the shipping uh the ship the shipping ID is joining the employee table. Now, this is not what we want. Okay? What we want is to have, our people table to be joined to the other table. So sometimes it doesn't get it right because, of course, you can see that I have other ID in my orders table, and I also have other ID in my people table. So why not he just join it together? Why is he selecting, the other ID in the people table and the other ID in the shipping table? Right. So although there'll be some database design or the modern design that you can join your people table to your shipping table. But that's not what we have here. So for this now, or if it doesn't, model the data very well for you, you can easily, delete that relationship. Right? So I can just come here now. Once it's been selected, I can just right click and I will say delete. I don't want this relationship. Now I can now manually, create the relationship between the people table and the orders table on the orders ID. So just press and hold the matching column from the order ID to the people table. So you can see it both has this name relationship tab, order ID from the order table, order ID from the table table. You can see many to one, and it is single cross filter direction. Yes, we're good. Then you click on save. Yeah, so we have successfully saved that particular one. So you can see now that we have, all of our thing, being well modeled. So you see why it is called the star schema now. So it's called the star schema because it takes shape of a star. Sorry, don't mind the way I do my start. Okay, let me try again. I think it should be like this. Yes. So this is the fact table. Why this is the dimension table. So these are dims. All these are dim, dim, dim. Yeah. So with this now, you are good. Then you can now start building your analysis. So the problem is that if you do not do that, you cannot select information from one table and select a column from one table and select another column from another table. Okay, so let me tell you what I'm talking about. So let's say I intentionally delete this relationship from the orders table to the shipping table. I deleted it. So there's nothing here. So this guy is like an orphan, it's a standalone table, the people table, right? So if I go back to my report now, so if I select, where's my order table? So I can't select any order here. I selected it and also select something from the people's table. Let's say the employee name in charge of those orders. So you can see it's not going to work. Can't determine, you see what it says? Can't determine relationship between the feeds because they are not related whatsoever. So you cannot select, information from one table and or select a column from one table and select another column from another table and expect something to pop up. No, because there's no relationship whatsoever. And the reason why we want to select because we want to know the employee in charge of each and every of the orders. Because we don't have the employee name inside of the orders table, right? And we don't have the whole information of the orders inside of the employees, inside of the people's table. You see the reason why we need to be join tables together so that we can take like bits of information from here that is lacking. They can take bits of information in table A that is not in table B and take bits of information in table B that is not in table A. So instead of having a long flash file, which is going to affect the speed and the performance of our model, right? So that is the reason. But now I'm going to remove this. But let's say we want to pick maybe something from others table, let's say the order ID, and we probably want to look at who is shipping this order ID, right? So I'm now going to select the carrier for each of the orders. So I'm going to select the carrier here. So you can see now that this work from different table. I selected order ID from the orders table and the carrier from the shipping table. So I can now see that, okay, my order ID 0001, it is being shipped by FedEx. 1002 by UPS, and so on and so forth. So this is because we have linked the two tables together. So I can select something from table A and another from table B. So now, let's just fix the relationship back so that it can work. I'm not going to say, okay, so order ID on the people table, order ID column, then so single and many to one. Yeah, so there we go. So that's the only way you can join equal. So now, if you now want to take any of this information now, so let me remove the carrier or no. So I've picked something from the other table. I've picked something from the shipping table. Then I'm now to pick something from the people table. Who is the name of the employee in charge of the orders? So I'll select the employee name. So you can see now. So John, Mike, Sarah, Emma. So all of these guys all this order do not have, that's what it means. They do not have an employee that is being currently assigned to them at the moment or as at that time that we pick out this order. So with this now, we can do any kind of analysis that we want to do. We can now probably say, okay, I want to see the the product name. So I'm going to open up the product ID. I'm going to see the product name and the quantity that was purchased. So I can put this in a clustered column table, a clustered column chart. So you can see. So the quantity that was purchased the most is camera, followed by table, staple pin, etc. So you can now do, so you can see I'm picking information from two different tables, one from the product table and the other one from the other table. So you can do anything that you want. If you have any question, reach out to me. I'm going to attend to it. If you want me to create any other, meaningful Power BI solution, reach out to me. You can drop a comment below, and I'm going to attend to them as fast as I can. Thank you for being attentive.